Yeah, thanks very much. So, yeah, I'm going to talk about my hydrogen journey from Supergen to the National Physical Laboratory, and I'll start with Newcastle University. So, I joined Ian Metcalfe's group at Newcastle in 2008, and I had a very exciting project. I enjoyed it a lot, actually. So, it was hydrogen production using chemical looping. So, the process we were looking at is shown here. The idea was to use an oxygen carrying material such as iron oxide or a perovskite material, and that material will basically transfer oxygen from, for example, water to a reducing gas stream. So you're able to do, water gas shifts or steam methane reforming, but you can produce the products without an extra separation step. And actually, this is a really good way to produce high purity hydrogen. So the hydrogen could be used for combustion, but more importantly, the hydrogen could be very, high purity for fuel cells, which is renowned for its susceptibility to degradation if there's, even very small levels of hydrogen sulfide at parts per billion. So it was a really interesting project that I was working on for 3 years. And obviously I did that as part of Supergen, so part of delivery of sustainable hydrogen. I went to quite a few of the meetings, and here's me giving a presentation at Cardiff 2010. So you may recognise the back of your head if you're also part of that group. So after Newcastle, I moved to MPL in 2011. They were looking to grow their hydrogen area, so I joined as a high research scientist. And my role was to develop MPL's hydrogen purity lab. So at MPL, we're really focused on gas measurements, we're focused on anything to do with measurements. So I was interested in any type of gas measurement for hydrogen. And hydrogen purity is really important because the fuel cell has a catalyst that can degrade quite easily. And at the time, around 2011, there was an important international standard that came out called ISO 14687. And this provides the guidance for hydrogen purity. And nowadays, every single refueling station around the world needs to comply with this standard. So my job at the time was to develop the methods that were able to, provide this kind of purity analysis, this quality assurance. So I spent, a lot of my past 10 years developing the methods and supporting companies like ITM Power in the UK to check the quality of their stations. And it's quite interesting because I think back in 2008, hydrogen was an interesting topic, but it wasn't very clear that it was definitely going to be an area that was, it's an area that was definitely going to grow. And I actually wrote an article on this for Connected Energy Solutions last month, so it's quite timely. And I think nowadays, obviously, there's a bit more interest. So there's Anthea Turner doing an interview on hydrogen for Anthea Turner Hot Topics. And over the past 10 years, things have changed quite a bit. So in 2013, there was quite an important project called H2 Mobility, where they predicted quite a large growth of refueling stations and use of hydrogen fuel cell vehicles over quite a few decades. Then in 2017, we saw the first public hydrogen refueling station opened by Shell. Last year, the UK government launched a 10-point plan for a green industrial revolution, and talks about hydrogen quite a bit there. This year, we saw the launch of the double-decker hydrogen bus, and I think this is important because I think it's quite clear that hydrogen can be used for the larger modes of transport, not just passenger vehicles. And this is these types of transport are the ones where batteries might not be suitable. So hydrogen has a big part to play there. And this year, we're also expecting to see the government launch a new hydrogen strategy. And as everyone probably knows, by 2030, the UK government's planning to ban the sale of petrol and diesel cars. So quite a lot's happened over the past few decades since I left Newcastle University. And that's just hydrogen transport. MPL is well connected with the gas distribution networks as well, and they're planning to use hydrogen quite a bit as well. So there's the Delivering the Pathway to Net Zero report written by the UK gas distribution networks. Right now, I think there's about 100 biogas plants injecting biomethane, but there are plans to start blending hydrogen. So 20% hydrogen natural gas is being tested at Kiel as part of the High Deploy project. But we're also working with SGN, Cadent Gas, and the other gas distribution networks to work towards 100% hydrogen in future as well. And we're also working with, sorry about my cursor, working with appliance manufacturers. So Worcester Bosch have developed a hydrogen ready boiler, and as you've seen from other presentations, other companies are working on other types of stationary fuel cell applications as well. But as I said, MPL are interested in the measurement challenges. So to support the gas distribution networks, we have started a new project called Metrology for Decarbonising the Gas Grid. This started this year, and we're looking at the measurement problems related to flow metering, gas composition, physical properties, leak monitoring. As I've got a short presentation, I won't talk about this too much. So if you are interested in the project or want to find out more, you can go on LinkedIn and find our group, and feel free to join it, and we can keep you updated on this project. What's going on? Sorry, it's not moving. There we go. Okay, so moving forward to 2021, I'm now PRS, so I'm leading the energy gases team, and the energy gases team is split into three big areas. So decarbonising heat, so this is for hydrogen and biomethane, hydrogen for transport, and the quite new area of carbon capture, usage and storage. So the gas measurement challenge there is that the CO2 purity is quite important. So we're working with the CCS operators to help them develop guidance and purity specifications for them to follow, because if there are any impurities in the CO2 during transport and storage, it could cause toxic leaks. If there's acidic components in there, it could cause corrosion of pipelines, or if there's high amounts of inert gases, it could lead to quite large inefficiencies during compression. So this is quite an interesting topic for us.
You've got about a minute left.
That's fine. Yeah, no worries. And the kind of work that we're doing at the moment are things like testing hydrogen refueling stations. So we're still helping UK refueling stations check the quality. We're still, we're also working on PhD students with the university. So we recently had one with Professor Kangley from Imperial. We're supporting standardization. We recently helped SGN develop new odorants for hydrogen. We also supported Cadent Gas to test whether gas grid hydrogen can be provided to refueling stations, and we have supported a new company, Sea Capture, to test their new CCS materials. I'll skip this page because I don't have time. So I'd like to say thank you very much for listening to my talk. Also, thank you, Supergen, because you introduced me to hydrogen, and I'm still working on it. I think it's a very exciting topic. So thanks for that. And also, Supergen, thank you for introducing me to my wife, who actually met for the first time at the Supergen meeting in Leeds in 2009. So cheers.